We have two different expressions represented on the mats. We can show each of these by writing an expression. To compare these two expressions, we can make zero pairs to simplify. Making zero pairs combines like terms, positive and negative like terms. When we do this in this example, we end up with 3x minus 1 and 3x minus 2. Another legal move we could use to simplify these two expressions are removing like terms from both sides. If we remove 3x from both sides, we are left with negative 1 on the left and negative 2 on the right. That tells us that the mat on the left is greater than the mat on the right. What does this tell us about the value of x? Take a minute to think about that. It seems logical that once we simplify both expressions and are left with no more x's, that the value of x is not relevant in determining which side is greater or less than the other. The only thing that is left when we simplify the two expressions are constants. So this seems to make sense that no matter what value x is, the left side will always be greater than the right side. How could we check this? We could go back one step in our expressions and try putting a variety of values in for x. For example, we could try negative 1, 1, 0, and smaller or larger numbers. If we did this, we would find that each time we ended up with the same value on both sides, but then took away 1 from the left, while on the right we would take away 2. When we subtract a positive, we'll always be moving towards the left on the number line, which will make each value smaller the further left that we go. Therefore, we can tell that the right side will always be smaller than the left side. This next example is different. We have already been told which side is greater or less, but our job is to simplify and isolate the variable so we can find out what value would make them equal and then what values would help satisfy the less than or equal to symbol. The first legal move we could do would be to add an x to both sides. When I add an x to both sides, I end up with 4x minus 1 on the left, and the negative x and positive x zero or cancel each other out on the right side, so I am just left with 3. The next move I could do would be to add 1 to both sides. If I add 1 on the left, my variable is isolated because the negative 1 and positive 1 zero or cancel each other out. And on the right hand side, I end up with 4. To find out what value for x would make these two sides equal, I can think logically about 4 times what number would be equal to 4, which tells me 1, or I could do the same thing to both sides, which would be to divide by 4, and then I would have x and 1 on either side from each other. Either way, I know that when x is equal to 1, both sides of the expression are equivalent. They are both equal to 4. Therefore, 1 is my boundary point. The symbol in between both expressions tells me that I want to know what would make these sides equal, which would include 1, so I would have a colored-in circle, as well as what would make the left side smaller than the right side, which would be anything less than 1. So I'm going to point my arrow to the left. Try this one on your own by pausing the movie. Use legal moves to simplify both sides and isolate the variable. Find out what m would need to be equal to for both sides to be the same, and that is your boundary point. When you are finished, press play to check and see how you did. I would begin by subtracting 1 from both sides, or adding -1. This would make the +1 and the -1 on the left cancel out, leaving you with 2m is greater than 4. I know that 2 times 2 is equal to 4, so my boundary point is 2. Since I want to know what values will make the left side greater than the right side, 2 will not be one of my solutions, because 2 would make them equal. However, anything over 2 would make the left side larger.